Our next speaker is Sandesh Patil from Luxembourg Center for Systems Biomedicine. His talk is entitled Deploying a FAIR-Compliant Research Data Management System with iRODS at the Luxembourg Center for Systems Biomedicine, University of Luxembourg.
Good morning, everyone. First, I would like to thank iRODS Consortium for giving me this opportunity to speak here. It's a real pleasure. My name is Sandesh Patil, and I work at the Luxembourg Center for Systems Biomedicine at the University of Luxembourg. Over the past 1 year, we have given ourselves an ambitious goal to give our researchers a platform which is governed and FAIR compliant. We did evaluate few existing systems and before building the platform, and chosen iRODS as the foundation. So over the next 20 minutes, I will talk about why we chose iRODS, the architecture that we have designed, the lessons that we've learned along the way, and I will finish by showing you the system running live in production. So before starting, I would like to tell you who we are and what we do. So Luxembourg Center for Systems Biomedicine is a biomedical research institute at the University of Luxembourg. Our main research focuses on brain and neurodegenerative diseases such as Alzheimer's and Parkinson's. And an important reason why this project got shaped is the fact that we are also a data coordination center for multi-site projects. So we run 8 different scientific platforms like genomics, metabolomics, bioinformatics, biobank, etc., which produces high volume of data on their own. And we also support clinical studies on top of that. So if you put all that together, we produce a variety of data at serious scale. Today, we have about more than 1 petabyte of data, mostly coming from our imaging facilities, sitting on a Dell EMC Isilon storage with a capacity of 12 petabyte. So in a nutshell, we are more than a research institute, and we produce a huge amount of data that required a home which is governed, structured, auditable, interoperable, reproducible, etc., which was challenging. And that brings me to my next slide about the actual challenges that we've had. So before building this platform, the data management at the institution was a bit of a mess. Our data was scattered across all over the places, like HPC clusters. We had OneDrive, personal and private drives, laptops of the researchers, email attachments, etc. There was no place to find a data set, no single place. So usually you had to go to the person who made it. Data was lost when someone left. So someone finishes their PhD, moves on, and their data quietly become unowned. Compliance was manual, so access was given by hand, project by project, which was error prone and hard to govern. So that's what inspired us to come up with this platform, which we call the LCSB data space. So now with this platform, we have a home for our data, which is governed, structured, and auditable. Finding, accessing, and sharing data is now based on a proper policy-based access control, and data is always retained and owned even after people left. Compliance is now part of the design, so platform manages the compliance and governance, and not left to the researchers to manage on their own. The platform is live today. In fact, it came into production just a few weeks back. But of course, there are some of the improvements that are still in pipeline. And at the back end of the LCSB data space, we have iRODS, and I will now tell you why we went with iRODS. So we did look at several existing research data management systems, and we realized that iRODS already underpins many of them. For us, it mainly boils down to three things. The first one was the policy-based management. So iRODS have rule engines that enforces logic at the data layer, and that really helps us to not re-implement that logic at the application layer for each application. Honestly, with rule engines today, we only use it for user management and provisioning, and for larger data and lifecycle. We are still building towards it, but the capability is there, and that's what matters. Backend agnostic, so we have Isilon storage attached to our platform today, but let's say a few years down the line, if we plan to move to another storage, it's a simple plug out and plug in without having to make any changes to the platform. And iRODS lets us attach the attribute value metadata to our collections and the data type, and then we can really use those tags to find the data, access control, and really throughout its life cycle. We are currently on version 5.0.1. We're using it using iRODS stock, and the custom logic it really sits around the modules around iRODS. So I will explain to that with the architectural diagram of our platform. So you see iRODS at the center, and the storage is attached to it. So at the core, we have data, metadata, and access control. And the easiest way to follow the diagram is how does the user get in and how does the data gets in. So this is iRODS. So these are the users. So there are three ways that user can access the platform. One is browser. Then we have a command line client and a programmatic access via Python and R. And all of them are authenticated via our institutional SSO key clock. And I will explain this in more depth in the slides to come. How does the data get in? So we have IBM Aspera, which we use for large file transfers. And then we have an ingestion module that validates those files, do the checksum, and before ingesting into the vault in a permanent storage. Another important component of the diagram is the data governance registry, which is DAISY. So DAISY is responsible for the metadata related to project and its membership. It's a source of truth for projects. It also holds metadata regarding governance, such as consent, legal status, classification, retention dates, etc. So DAISY provides to provisioner, and provisioner is responsible for creating iRODS account automatically, creating iRODS collections, attaching control lists and AView metadata. We take regular backups, in fact, nightly backups of our databases for security. And now I will go through some of the flows in the diagram, starting from the authentication and provisioning. So, as I said, we use key clock. We call it LCSB SSO. That's the institutional SSO. So on a normal laptop, that's your browser. On a headless machine or an HPC, we use a device flow where user gets a URL and a code for authentication. Access via programmatic access and access via client CLI is brokered through iRODS HTTP API. So we never really expose the raw iRODS credentials to the end users. Authorization happens via DAISY, so it knows who is in which project. And at the time of first login, we have provisioner scripts that creates their iRODS accounts, collections, and ACL. So basically, on the first login, we define the scope of the project's data. Excuse me. User don't really need to request an access or create a ticket. They just have to log in with their credentials and they have automatic login. On subsequent logins, we also synchronize with the DAISY so that it always reflects the current status of their project. Moving on to ingestion pipelines. So data comes from several sources like external submissions, the outputs from the scientific platforms, or the data sets that our researchers generate internally. So there are 4 stages for large file. We use IBM Aspera, and at the staging, we do the checksum verification so as to maintain the integrity of the data. And then ingestion module is responsible for validating those files, creating iRODS collections, and attaching the relevant AVU metadata before it goes into the vault as a read-only. And all of this is automated, so user doesn't have to run any pipelines, and the data just appears where it should be. About accessing the data. So for web browser, we use Mango from KU Leuven, who will probably be speaking in a few moments from now. So I'm excited to hear updates from them. But in the Mango portal, you can browse and download, upload the data, visualize metadata. For the command line access, we have a tool called LCSB iCommands. The good thing about it is it wraps around the original iCommand. So anyone who knows iRODS immediately feels at home. It's a simple pip install. You log in with your device flow, and you can access your collections. It's built on Python, cross-platform, and HPC friendly. Programmatic access via Python and R is something that we're still working on, and we would want to give that to our users so that they can integrate into their pipelines their collections and iROD. Moving on to dataset lifecycle. So we believe that data has a life, not just a storage location. So when the data is ingested into the platform, it is locked, and then it stays active for a while, where every action is logged, and we do notify users via automatic emails about all the important events, starting from the ingestion. A resubmission of a data set creates a new version instead of overwriting the old one. And when data becomes inactive, it's either retained, archived, or deleted, depending on the policy. Many of the things are already live today, and some are in development, which we hope will be rolled out very soon. Also happy to announce that we have developed a AI chatbot assistant, which is integrated into our portal. So the difference with this chatbot is it combines 2 entities. So it retrieves data from the standard documentation of the platform, and it also retrieves the live ACL of the user's own account. So basically, it has access to the user's data, and it can answer the user about his own data in natural language. Because most of the researchers are really nowadays using chatbots, and this is one of the feedbacks that we've got from our researchers, which is why we thought it is good to develop a thing like this. So, for example, user can ask which projects can I access, or has my submission been ingested yet, and the chatbot access the user's live ACL to answer questions in plain language. If the user tries to access a data set that he or she is not entitled to, the assistant will restrict it and inform the user that he should and how he should request the access. It's self-hosted. We have it on our infrastructure, so because we deal with sensitive data, so for the security purpose, we need to have it on our infrastructure. It is already live on the portal, and we are also working on making it available for our command line clients. So the final slide before the small demo, the lessons that we've learned in last 1 year. In technical aspect, moving because we started with iRODS 4.3 and then we've migrated to iRODS 5. And we did break some things in Python, iRODS clients, and HTTP API. So my advice, if anybody developing something similar to this or on these lines, I would advise you to pin your versions first and test the upgrade because before you try the migration. The login token is also a part that was a bit tricky. So in our case, Keycloak creates the token and then it travels across all the components, starting from the portal, our CLI server, HTTPI client, and iRODS itself. So they see their own part, which seems simple, but combining them and making them work together for refresh and expire token can be a bit tricky. On the operational front, getting cross-team agreements can save you a lot of time. For example, a term collection means something in iRODS, but it means something in our governance registry DAISY, or it could mean something in the day-to-day lab work. If you're syncing with an external system, it's always going to be slow. So for a better user experience, I would say if and whenever possible, make sure that the sync is in the background and it doesn't hamper the user experience. So this is the landing page of the LCSB data space. User logs in using the SSO, put your credentials, and then you're in. At the left, you see your collections, projects, search, metadata schemas that you can go through. The projects, these are the projects that are that comes from the DAISY, so these are not manually inserted. And then if you go inside a project, you can visualize the data, you can visualize the metadata, everything that is attached to it. And then for the chatbot, you can basically ask once you log in, it identifies you, and then you can ask questions like which projects can I access, and it tells you specifics regarding to your data. And if you ask like a general questions, it will fetch information from it, retrieve the information from the standard documentation and give you a response. And finally, the command line client, so it's just easy pip install, and then you can basically, once it's installed, you can do init. It gives you a URL. You can either click on it or copy it into a browser, and then authenticate using your Keycloak credentials, and then you're in, and then once you're in, you can simply use the normal commands to visualize your data or to download your data. Yeah, you can see the data inside the data set, and you can use iGet to download it. So that is it. Thank you for your attention.
Have any questions? We got one right here.
Thank you. That was great. And welcome. Glad you could be here. The DAISY service, I find very interesting. I've seen that pattern in a few different places. Is that a custom thing, or is that something that you found somewhere else and are using?
Well, I am not responsible for DZ, so there's another team, and it was already there before we started working on this platform. The fact is, we use DZ because we don't want different sources of truth. So we don't want iRODS to put projects manually and use it. So if the data set is already there and it's active, it's always better to actually sync it with that governance.
Right. That's a universal service.
Yes.
And it already existed before this.
Yes.
Do you know if the university built it?
Not in university, but LCSB. But yes.
Okay.
We've built it. There's another
Oh,
team
you built it before, or somebody else built it before?
Yes, exactly.
Okay.
Yeah.
Excellent. Thank you.
Do we have, okay, yeah.
No, okay. All right. Yeah, thanks for the talk. Looks like a lot of thought and care went into that design and system. So I have a question on the ingest part. So you said that you ingest data from like facilities and also from researchers, internally generated data set. Could you describe a bit more how the ingest happened, like practically, for example, for a researcher? Like to which collection or which project or something it would go? How does it work in a practical?
Well, it's a bit complicated to answer that purely because in LCSB we have different platforms and they have different standards. So everybody uses different services. They have their set of practices. So for us, ingestion is very specific. We need to talk to the platform. We need to understand how their data gets produced. For example, some of the data is pulled directly from the instruments. So then we connect the VM instrument to iRODS, and then we fetch the data whenever it's available. Sometimes it's the process data that is produced by the researchers themselves. And then we have another service called data submission service, in which they are supposed to submit their data, and then we pull it from data submission service. So when the data is ready, it's checked, it's approved by the supervisors. We pull API from the data submission service, and once they say the data is ready, we transfer it to the iRODS storage.
Okay, thank you.
All right. Thank you.
Thank you.